guys, so today, as you could probably saw on the Facebook post, we're going to go over the Pandas library. And this is a pretty fundamental library for data analysis and data science in general. And thus it kind of translates over to a lot of machine learning problems. And the main reason why we use this library instead of just using inbuilt Python functions is that it's made to handle large amounts of data, specifically data that's in an ordered form and data that can easily be worked with. And it performs calculations a lot faster on large data sets than regular like Pythonic functions, which would require the use of like for loops or like some sort of loop structure to iterate over large amounts of data. Well, in Pandas, you can just do it with like single line of code and a single kind of pass to the data. So today we are going to start off with a review of sets, because if you remember last time, we kind of had to rush through everything because we were running out of time. So we're just going to quickly review sets from last time. Then we're going to go into a problem that I wrote for 5 minutes. And this problem is like a pretty basic problem. It's just involving loops and some of the stuff we learned in week 1 and 2. And that'll be about 5 minutes. And then for the rest of the time, we're going to spend talking about pandas. And we're also going to have a little bit of math with regards to matrix multiplication, but it's not going to be super deep, just some basic stuff. So yeah, let's get started. All right, so the first thing that I want to talk about is reviewing sets. So let me share my screen. So you guys can see my screen, right? Yes, yes, no. Can anyone confirm?
Yeah.
Yep. Okay, cool. So sets. A set is a data structure. I'm just going to review the whole thing. So sets data structure that stores unique values without any order, and you cannot access items in a set by referring to an index or a key, but you can look for specific values in a set by using the in keyword. So we talked about all this stuff, and the most important things are sets are really useful. The two kind of areas of problems where sets are really useful are: one, if you want to get rid of duplicate values, or two, if you want to find like the intersections between like two lists or two I guess lists of information. So that, or like find like the intersection or the union, or find some sort of comparator between those two lists. That's kind of where sets are important. And I don't think that's actually all I want to talk about sets. I think we covered everything else, right? Yeah. All right. So first problem I want to quickly ask for someone is, what is the differences in instantiation of a list, tuple, and a set? So does anyone want to answer this question? Anyone? Just raise your hand if you want to answer. I'll call on you. Yes, a rule.
Does it have something to do like with like the braces? Like, isn't like, oh, okay.
Yeah. So what are the differences? So what type of braces do you use for lists?
Square?
Yeah, use square brackets.
Oh, okay.
Tuples?
Parentheses.
Yep. And then for, oh, oops. I meant to put not sets, dictionaries, though, what I wanted to use, but here. Sorry about that. And dictionaries, what's the instantiation for that?
Braces.
Yeah. Right, good job. So I think you guys got this down, and I'm hoping by now you guys feel pretty confident with the basics of Python. So we're gonna do this quick assignment, which will basically be pretty simple. You just need to calculate the average rainfall over a period of a certain number of years. So we're gonna use a nested loops to do that for now. And this program should first ask you for the number of years that you want to do. And the outer loop will iterate once for each year. And the inner loop will iterate 12 times, once for each month. and each iteration of the inner loop will ask the user for the inches of rainfall for that month. And after all iterations, the program should display the number of months that the user requested, the total inches of rainfall, and the average monthly rainfall for the entire period. And we want you to use for loops, custom and a custom function to calculate the average, and along with obviously input for use from the user. And if we haven't talked about this yet, or if you guys don't remember us talking about this, in order to get input, it's actually a lot easier than like Java. You can just use this function called input, and then you can ask your question in here, and it'll print it out. So, for example, say I want to store I don't know, like what is your name inside of temp, and then print it out, right? I run this, it'll give me this like pop-up, and I can type in my name, and it should print it out. So that's kind of how input works, and it's pretty self-explanatory. And yeah, so this is like a pretty basic problem, just a quick review of everything we learned in the first 2 weeks. So if you guys could quickly do that, and then once you're done, just raise your hand, and yeah. And I think actually, instead of me typing out your response, just copy paste your, if I call on you, copy paste your response to the chat, and then I can just copy it, so that'll be easier. So yeah, so just work on that for about 3 minutes, so to 3:27, and then once you're done, just raise your hand. So anyone have any answers, like code for this? Anyone? It's 3:27. Anyone have any answers? Anyone close to an answer? You guys can see my screen, right? I mean, it's fine seeing the question, right?
Yeah.
Just let me know.
Yeah, I think we're just typing in right now.
Okay. I'll give you guys.
Paste it in chat, right?
Yeah, so once you're done, just raise your hand, and once everyone raises their hand, I will call on someone to paste their solution in the chat. Yeah, so you don't do that almost like calling you. Yeah. So once you're done, just put up your hand, and yeah. All right, anyone got an answer? It's been about five minutes. Anyone? Is there any part of the question that's unclear to anyone?
Sanjay?
Yeah, what's up?
So the input, I think it takes it as a string, right? So how do we convert that into an integer?
Yeah, so that's actually a good question. Yeah, so Arul is definitely completely right. When you take an input, it starts out as a string. For example, you guys can still see my screen, right? So if you went back and said years equals input, how many years, no, a number of years, something. So, right? And then if you print out the type of years, right? Once we get that, so say it's 12, it's going to say it's a string, right? So then we run into an issue. But remember, if you think all the way back to, I think, the first lesson, we talked about this typecasting in Python, which is made really simple. So all you got to do is just say, like, it's called a string years to make it easier. So then you just say years equals the int of string years. And then now, if you do type of years, it should be an int. And then now you can do like a for loop with that or iterate through that. Does that make sense?
Yes, thank you.
Cool. Okay, Abinaya is done, so one person's done. I'll probably give everyone 1 more minute because I want to get to everything else, right? So I don't want to spend too long on this. So 1 more minute for this, and then we'll see who else is able to be done. All right. Okay. So two people. Since I called on Abinaya, I think a few times over last week, let's go to Anurag. So Anurag, can you copy paste your solution into the chat? Just copy it and then I'll copy paste it in and we'll see if it looks right. All right. So okay, I don't know why it formats it like this, but all right, whatever you tell me. Okay, so he initializes all his variables here, right? So it looks good so far. And yeah, so he typecasted it like that. Okay, that looks fine. I think this looks fine overall. Yeah, this should be fine. Yeah, so we can test it by just tabbing that over and then quickly fixing that. Looks right, I think. So let's say we do 5 years, and actually, no, I probably should not have done 5 years. Let's cancel that. What the heck? Why is it not stopping the kernel? Hello? Okay. Why is it not doing this for me? So let's just quickly just type in a few numbers so we get to. Okay. So that looks right. Oh wait, hold up. All right, so you seem to have an issue with the final division.
Total rate. The month count needs to be tabbed over one more.
Oh, my bad. Okay. We'll just do this then. Yeah, that should be right. Wait. No, this value, wait, 78. Yeah, that's right. Okay, just kidding. That's right. Okay, cool. Good job. So yeah, this solution does work, and yeah, good job, Anurag. So we spent a little bit more time than I wanted to on this, but I think you guys should have a pretty good understanding of basic Python syntax by now. So you can probably just move on from talking about data structures and some Python syntax and start talking about specific Python libraries. All right, so today we're going to be talking about pandas, like I mentioned, and we're going to use this other thing that you guys probably have not seen before, which is called Google Collaboratory. So this is basically, or Google Colab for short. So basically, this is like an equivalent of Jupyter Notebook, but it's online. So say like a lot of people, for example, don't have the computing power that they need in order to run like machine learning models on their own computer. So instead, they use Google Colab, which gives you basically like some resources. So for example, if I check here, I can see that like Google allocated like this amount of RAM and disk for me to use in my session. And yeah, so some of the benefits of Colab is like if you're running like large models and you don't have like a GPU, for example, you can use Colab instead. The issues with the Colab are that all the data that you upload to Colab is all temporary. So for example, here, we only have 70 something gigabytes of disk space. So if you have large data sets, you can't use Colab unless you have Colab Pro. But anyway, all right. So let's quickly just introduce Pandas now. So Pandas is built on top of this package called NumPy, which we haven't really talked about, but we'll talk about it more next week. And this basically just means that a lot of the structure we see in NumPy is replicated in Pandas, and Pandas can be used to do statistical analysis, plot functions, or even run machine learning algorithms, specifically through inbuilt libraries. For example, one of them being scikit-learn. And you can ignore this. So the first thing we're going to do is actually install Pandas. So if everyone can navigate to a Jupyter notebook, or you can open Colab, whatever you guys prefer. But if you guys want to stick with Jupyter notebook, just open that right now. And the first thing I'm going to do is type in this command here. So you put exclamation point. Exclamation point just means tells Jupyter notebook that you're running a command line. You're running a command line argument, and then you run pip install pandas. And pip is just a package manager, so you just install using pip. So everyone can do that right now. If you run into an error, just raise your hand, and Sam will help you if you run into an error with that. But I don't think anyone should. So everyone's good at that? You guys were all able to install, run this and install Pandas? Right. So everyone got this requirement satisfied and they were able to successfully run this out. If you were able to run it, raise your hand so I can make sure that everyone is doing good. All right. So we have 2 people, 3 people. Okay, cool.
Wait, I didn't hear you before, but you ran it in the Anaconda command, right?
Oh yeah, you could run it. You could run this through Conda also. So you can do Conda install Pandas too. You can run it through either. Yeah. But you got pip is easy too. Both of them work honestly. So whatever you want to do is fine. All right. So most people: Harrison, Michael, Sam. Oh no, sorry, not Sam. Ifan, Pearl. Okay. Everyone else, are you guys having issues, or like Harrison, Michael Lee? Okay. So I think everyone got it now. Okay, we're good to go. Cool. So next we'll talk about how to import it. So importing libraries in Python is like very simple. All you have to do is just say import whatever library, and then you have this optional thing where you can say as something. And basically all this allows you to do is like reference the library in a simpler way. So say we could easily just take out as PD and just say import pandas. And then when we reference pandas, we have to say like pandas dot something. But if you say import pandas as PD, whenever we run any pandas command or function from the library, we can just say like PD dot or like PD dot like join or PD dot data frame or something to create a structure. So next, let's import that. And next, let's actually look at what pandas is. So Pandas is basically built on these two ideas. The first is this idea of a series, and the second is this idea of a data frame. So basically what a series is it's essentially a column, and it's basically a vector that just has values. So you can just think of this as a single column in like an Excel file. So for example, if we have this series right here, we have that there's one column and it's just apples. The apples is kind of the column name. And then we have these different rows. And usually when you talk about series, you call these rows the row like values, like 0, 1, 2, 3. You call them row indexes or indices. And in the middle, you have the values. And then here we have another series, but this time it says oranges. And here we have a data frame. So basically, a data frame is just a multi-dimensional table that's just a bunch of series put together. So we put together the apples and oranges series, and we get this data frame. And data frames and series are really similar just because of how they're structured. And a lot of this, you can use a lot of the same operations in both of them. And now let's just quickly get into them. So let's not spend too much time on theories. Let's just quickly get into creating a data frame. So there are actually quite a few ways you can add data to a data frame. So first is you can use a file, like something called a CSV file, which are very common, which stands for like comma separated value file. So basically, you can take an Excel file and you can save it as like a CSV and import it. That's the first way. And you can also do that with something called a JSON file format. So those are like the first. That's the first way of doing it, through like a separate file. Getting your data through that. The second way is defining like a list or a dictionary, and then making a data frame out of that. So for example, that's what we're doing here. We're using this dictionary to make that. And lastly, we can define the values inside the data frame when we actually call on this data frame function. So those are 3 ways we can do it. So we're looking at the second way right now with this dictionary that's called data. So here we have basically this dictionary is basically what's shown up here. So we have apples mapping to these values and oranges mapping to these values. So if we create a data frame out of that, run this style, we'll end up with purchases looking like this. And this is basically what we saw up here, right? So now let's talk about how we can access values or perform operations on this data frame. So each key value item in the data corresponds to a column in the resulting data frame. So the index of the data frame was basically predefined for us, but we can also create our own indices by like specifying them here. So we can pass 2 additional arguments here. So one is going to be like this index argument, which will basically just be like a set or like a list of values that are equivalent to the number of rows in the data frame. So that's the first parameter we can pass. And the second parameter we can pass is this columns parameter. And basically this columns parameter just is the column names in case we want to rename the columns. And the columns parameter should be a list or an equivalent data structure that is equal to the number of columns in the data frame. All right, so enough on that. So let's move on to the next cell. So in this case, we're seeing how they use the index. So initially we started off with the indexes being 0 to 3. So the indexes are, when you define a data frame, they're automatically just going to be 0 to whatever the 0 to the number of rows you have automatically. You can change that using the index parameter, where you can pass a list that has strings or other numbers in case you want to use more convenient indexing. So here we're redefining them to names. And now we can use this interesting function called LOC. So I think it's worthwhile just talking about 3 ways we can access data right now. So let me quickly add a cell file. How do you add a cell? Text cell. All right. So there's 3 types of accession. 3 types to access data. So the first is using this .loc function, right? And this is basically used when when you're trying to index by a non-integer parameter. So in this case, we're trying to access this entire first row by using the index, which is not an integer, it's a string, right? So we're trying to index this entire row using the string. So used when you're trying to access data with a non-integer parameter. So in this case, June is a string. So that's why we use LOC. The second accession method is .iloc. So this one is used when you're trying to access data with an integer parameter. So you would use .iloc if you had this data frame up here and you were trying to get the first row. You would say like purchases.iloc 0, and then we get the same thing as we got here. We get the exact same actually. And the last thing is this kind of convenient function called .ix, and basically this is used when you are trying to access data with both an integer and string parameter. So I think a good example of this is like if we go back up here, right? So say we're trying to get this value specifically. So not the entire first row, but just this value that's like in the first row and the first column, right? How we could use a single indexing like methodology to do that by saying like purchases.ix of, so let me write this down for you guys. So purchases.ix of whatever, so 0, right, comma, and then we can say apples, and we can run it like that. So yeah, that's where ix is useful. So ix is kind of like a fallback option, and when you like aren't sure exactly if your values / column values are integers or not. For example, if you're running like a for loop with this. But yeah, so these are 3 different accession methods. So we just talked about LOC. So if we run this, we get what we expect, which is the first row. And now how can we read in data? So if you think back to about 5 minutes ago, I was talking about one way to read in data is through files. So the 2 file types that are really used with pandas or functional pandas are CSVs and JSONs. So both of these are different, and I don't really want to explain them. CSVs are easy to explain. It's just like you take data that's in like an Excel format or like a table format, and you basically just separate them by like a delimiter. So for example, if you had this data in Excel, you would basically end up with something like this in your final thing. You'd have like June, 3, 0, then Robert, 2, 3, with the delimiter being the comma. And you could replace the delimiter with whatever you want. So you could replace the delimiter with like a hyphen, and it'd be the same thing. So that's basically how that works. And yeah, so we can run this. Oh, right now we don't have a purchases.csv file, right? We don't have this somewhere here, so I'm not going to run this for now. I think we do have a page. Maybe I have this. Wait. Hold up. I'll only go find this file. I think I have it somewhere, but give me a second. I have to go find it. Articles, master. Okay, I do have it. All right, so let me upload this and that. Okay, cool. All right, so all I did was I went to files and then I uploaded it. So if you guys ever want to upload files in Colab, you just upload them through here. So now we have purchases.csv in our directory. So if you run this, it should print out a data frame. So we have a data frame here, and the first column is unnamed for some reason, that they didn't give it a name. So we can talk about how we can rename this in a second. But for now, we have these 3 column names: unnamed, space 0, apples and oranges, and then we have names the first column and the number of apples and oranges that they have. So now, say we don't have an index in our CSV. So most CSVs, when you create them, they don't have an index. So what we do is we specify an index column. So when you rerun this, we will specify the indexing to be the names rather than it being in the normal indexing. So this is good if you don't want to deal with this like unnamed, I guess, column, which you might see if you're using data frame in like an Excel file like this. But yeah, so that's where you use this index call parameter. And this basically just reassigns what the index is going to be. So basically you're equaling the index to be one column. Now we have a JSON file. I think I also have a JSON file somewhere. No, I don't have a JSON file for this. Okay, never mind. So we'll skip this. But if you just rerun this, we run the read JSON file, you'd end up with the same data frame. Okay, so now we can also quickly talk about how you can convert back to a CSV or JSON. So say you have like a fully flushed out data frame, like you did some pre-processing, you did some analysis with your data frame, and now you want to resave it back to a CSV, which can then be imported into like Excel for you to view. You can use this toCSV function, or you can use the toJSON function. So both of these work pretty well. And this is basically the only two data types you'll be using when you work with files. Okay, so now let's go look at a real data set and show you how we can perform different operations. So here we have this IMDb movies data set. And basically what this is just a bunch of movies along with the ratings they got. And this is like, if you guys have like done any, I guess, elementary machine learning before, you might have seen this data set before. It's very, very popular. But yeah, so let's get into it. So first, let's run this first cell. And so now we got our data frame. We loaded it as a CSV. So you read the CSV from our files, and we set the indexing to be the title of the movie. So now we're going to talk about this function called head. So if you guys have used like a Linux system before, you might have like seen like head and tail before. So like with regards to files. So if you want to get like the first few lines of a file in like a Linux system, you'd use the head function. Or like head parameter argument. And here we can use the same thing. So in Pandas, what basically head does is it gives you the first X number of files. And if you don't pass a parameter, it's automatically going to be set to 5. So in this case, we'll get 5 files. So we'll get these 5 movies. So the first is Guardians of the Galaxy. Second is Prometheus. The third is Split. The fourth is Sing. And the fifth is Suicide Squad. And then here we can see we have a lot of different columns, right, for these movies. We have all of these columns, and they all are useful for different things. But say we want to get like only 3 lines, we could just specify 3 as our parameter or argument in that function, and we only get the first 3 lines. So now we can use the tail function, which is basically the opposite of head, to get the last like 2 lines in this example. So in this case, we'll get the last 2 movies. So Search Party and 9 Lives. And it seems like the data in this data set is ranked. So basically Guardians of the Galaxy is the most popular movie in all of these, and 9 Lives is the least popular. Although I haven't watched either of these movies, unfortunately, so I can't tell you if this is accurate. But anyway, you can also use the .info command just to get a little bit of information about your data. And basically what this will give us is the different number of columns we have and the data types in these columns. And then it'll also tell us what overall data types are found in our data. So we have 3 float 64 columns, 4 int 64 columns, and 4 object columns. So usually, like the way you should think about this, floats are just going to be anything that has decimals in it. Ints are obviously going to be integers, and objects are going to be anything that the pandas reads as a string. So if you see like an object like column, it's most likely just going to be a bunch of strings in that column. We also get some random stuff like memory usage, which we don't really care about. But anyway, so the info is kind of a useful function. And now we can get the shape. So the shape gives us basically the number of rows and the number of columns. So the first parameter it gives you is actually it gives you a tuple. So it gives you a tuple of rows, comma columns. And if you guys remember back last week when we talked about how we can unpack tuples, we could basically pass parameters to get the shape. So we could also say something like this: A comma B, or rows comma columns, I think it's more informative, equals movies data frame dot shape. And if you run this and say we want to print out rows and columns, we would get 1011. So this right here is called unpacking a tuple, by the way. And yeah, so that's all that you guys need to know about that. So now let's talk about how we can handle duplicates. So right now this data set does not have duplicate rows, but sometimes it's important to verify that you aren't like working with duplicates just in general. So let's simply figure out how to work with this. So first thing we're gonna do is double our movie data set by appending it to itself. So if you guys remember lists, we could use this append function to add values to our list. Same thing with Pandas data frames. We can append them to each other. So now we just put basically the two movie data sets back to back. So we basically took the first data set and copied it and put it beneath it. So now we should have a 2,000 row data set, which is what we see. Yeah, and dot append is also like a copy function. So you can use it as like a way to copy the original data frame. And now we can use this drop duplicates function, which will basically drop any duplicate rows we have. So if you look at the parameters for duplicates, you can see that once you run this, we'll end up with only 1,000 rows because it'll get rid of all the duplicate rows. And now this is like a good example of why Pandas is so powerful. Because look, in what we did in one line, it would take us like probably like two to three lines and a for loop, which would be more complex to actually drop all the duplicates, right? Because you have to loop through all of them and keep track of which ones we've already seen. It's a lot of extra work. But with Pandas, we can do this in one line with a simple function. All right. And oh yeah, okay. Another thing I want to quickly mention here is this in-place parameter. So if you guys noticed up here, we have to drop the duplicates of this data frame, right? And then we have to reassign that to the data frame value. So that's like an extra like phrase we have to type, right? But say we don't want to do that, and we want to basically drop the duplicates without having to like reinstantiate or reassign the value of the data frame to itself. We can use this in place function. So this will give us the same thing. And if you look at the if you look at the oops, if you look at the shape of the data frame, it's still going to be the same, right? It's still going to have that 1,000 by 11 shape of the data frame. But say we didn't put this in place equals true function. So if we went back up here and recopied it, if you recopied it, so reappended it, and then you added a code cell saying, right, and we ran this, and then we looked at the shape wouldn't actually change. It would still be 2,000 by 11 because we didn't reinstantiate or reassign it to the value of the new data frame to itself. But if we use this in-place function, it goes back to normal shape. So that's why in-place is useful. All right, moving on. Okay, so now let's look at columns. So right now we've been looking at rows so far. So now let's look at columns. So if you want to get the names of each of the columns in the data set or the data frame, we can just use the dot columns parameter function, I mean, and we can get this kind of list. So if you look at the type of this, let's assign the columns to something. So if you get the type of this, it's actually going to be interesting. So we basically get this weird Pandas specific data structure, which is called an index. So we get all the indexes basically in that make up all the columns. So this basically data structure, I guess, or data type is not really compatible with a lot of things. So if you want to use like the columns, for example, or iterate through them, a lot of times you might have to convert it to like a list or some other data type that's more friendly. But anyway, that's kind of an extraneous point. The main point I wanted to say is that you basically can get all the columns in your data frame and use them for whatever you want. So you can iterate through these columns and say like for each column in the movie's data frame, we can do something with them. I don't know, but yeah. And not only does this come in handy if you want to rename columns, It's also useful when you need to understand why you're receiving like an error when selecting data from a column. And we'll talk about this later, what a key error is. But for now, let's talk about the rename function really quickly. So currently we have some weirdly named columns, right? We have runtime and then we have space in minutes. But like working with columns, this is a side note, but working with columns that have like a space in them in the middle is usually very hard because when you like call on the column for something, a lot of times it might be hard to get the value because Python's obviously going to be case sensitive. So if you put Sorry about that. I think my Wi-Fi just dropped really quickly. So where was I the last time you guys heard from me?
Talking about the space.
Oh, about the space. Okay, so it was just a quick drop. Okay, that's cool. So we can rename these to more convenient names, and that's what we do here. And remember, we use the in-place equals true function so that we don't have to reassign movies data frame to itself. So we run this really quickly, and if you look at the columns are exactly what we want them to be. Cool. So now let's talk about this idea of imputation. So whenever you work with data, right, in the ideal world, you have all the data you need to do analysis with. But if we're talking like practically, right, a lot of times it's impossible to get some data just because of whoever collected the data, the nature of the data. So a lot of times it's usually missing data. So the question then arises is how do we deal with this missing data? So kind of two options doing this. The first is getting rid of rows or columns with nulls. And the second is this technique called imputation. So the first is often not very practical, right? Because if we have this huge data set and we want to maintain the number of rows slash like samples we have in it, it's oftentimes not practical to just get rid of all the rows that have missing values or all the columns with missing values. Then we have to use a technique called imputation. So imputation can be very simple, but it also can be very complex. So you can impute like a column with values based on the median of the entire column. So that's like a very simple calculation, right? You just sort the entire column and then figure out what value is the median. But you can also use these very, very complex algorithms that are like use some like linear algebra and like calculus and stuff. I actually don't even know how they work, but I know some of their names. For example, one is called CART, and that's like a very popular imputation technique. I honestly don't even know what the math it does is, but it imputes really well by using these plotted and like fitted functions. But anyway, that's beside the point. So first, let's figure out how many null values we have. So we use this isNull function to get that. So we look at how many both cells in our data frame are null. Well, right now, when you look at this, right, we don't get any information, right? Like we can't figure out whether, for example, like the 500th row is false, right? Because we just can't see it on our screen. So it's more practical to use this function called .sum, which they show right here. So if you run this, it'll tell you the sum of each column and how many nulls there are. So if you look at this, it seems like most columns have all the values there. Some of them don't, right? So 128 rows or entries or movies don't have revenue, and 64 of them don't have a meta score. So we have to deal with that somehow. So the first thing we can do is we can just say, let's just drop them, right? So if you drop all of the nulls, this is, by the way, dropping by the column. So this will just drop all the columns that are null. So if you do this, we'll end up with 838, right? Which makes sense because if you do 838 plus these values, right, we should end up with 1,000, which is what we started with. So if we dropped all the NA values, we end up with 838. And this will basically just delete any row with any single value, with at least one single value in it. And obviously you can use in place equals true again here. But now say we want to drop columns with null values, we can use this drop NA axis equals 1. So axis just specifies whether you want to deal with rows or columns. And generally, the axis is always going to be set to 0, which means rows. But if you want to set it to columns, you just say axis equals 1. So we drop it by drop all the rows, and now we're just left with 9 columns instead of the 11 columns we had initially, which makes sense. So now let's do some quick imputation. So, like I was saying earlier, imputation is a conventional feature engineering technique. Like every single machine learning or data science project you'll probably ever do will require this. So right now, I don't want to get into complex stuff and get you guys confused. So we'll just talk about how to impute with the mean and probably the median. So let's first get a column that has missing values, right? So the revenue millions column has missing values. So if we get all the values, hold up, what happened? Okay, so here we got a key error. So, okay, the reason why we got a key error is because, is the column called revenue millions or capital R? Check. Oh, it's capital R, that's why. All right, so this should be capital R. Now we get the value of that. Wait, let's actually. All right. So here we get all the values in the revenue column. And so this is how much money they made in millions, right? So Guardians of the Galaxy made a lot of money, and 9 Lives didn't do as hot. But now let's take a look at how we can get certain values from that column. So remember, this column is now considered, like if you look at the type of this column, right, you type revenue, we will be told that it's a series. Because remember, data frame is you have multiple series and multiple columns, but if you just get a single column, it's going to be considered a series. So now when you're working with the series, we can use the same functions, right? We can use the head to get the first 5, and next we can do imputation on this. So first thing we can do is we can call this really convenient function called mean. So mean understands that you're looking at that specific series, and it's a series specific function. So you only use the mean function with series. So when you run this, you get the mean for this entire column is 83 million approximately. And now we can basically just say, let's fill all the values using this fill NA function that are null with 83 million, because that's the mean. So when we do this and we say in place equals true, that means obviously we're going to make the change permanent. So we're not going to have to reinstantiate the revenue series to itself. So now we filled it up and we're good to go. So now let's quickly just check that we are doing this correctly and we have no values missing. Okay, so we have no values missing from the revenue millions function and we're good to go. One other thing I wanted to point out, which is important, is that notice by using the in place equals true function, we have actually affected the original movie's data frame. So this is a very important point. So when we first called this series, which was a part of the movie's data frame, Pandas still holds a reference back to the original data frame, which means that when you say in place equals true and you fill the values, it's going to actually affect the original data frame of which the series is a part of. So this is a very important point that you guys should know, that Pandas still stores a reference back to the original data frame. All right, so now we can use this cool function called describe on the entire data frame to get a summary of the distribution of the variables. So this will basically just give us everything we need to know about the variables. So we can figure out the number of values. So all these are going to be 1,000 except the last one because it has missing values. Then we'll get the mean, the standard deviation, the minimum value, the 25% or the first quartile, the 50%, or the median, which is the second quartile. Or sorry, this is the median, I think. And then 75% should be the third quartile, I think. Yeah, and then maximum, which is the maximum value. And understanding which numbers are continuous is also very handy. And describe can also be used on a categorical variable. So it's not only used for continuous, it can also be used on categorical variables. So this is not a column called genre. Oh, it's capital G. So we can run the same value and basically just get that the unique counts we have are 207 and the top frequencies are action, adventure, and sci-fi in terms of genre. And we can also get the frequency of the frequency just means the number of those. So, for example, if we did this to look at the total number of unique genres, use this dot unique function. And if you run that, let's figure out the number. So we use this len function on the outside to figure out the length. And what is that now? So yeah, there are 207 unique values, which is given up here. And the frequency just means the frequency of the top category, and the top is just the top categories. All right. And lastly, this really cool value counts method or function, which basically allows us to figure out the frequency of all the values in a column. So if you run this, you'll see that the first category, which is this action, adventure, sci-fi, has the most movies at 50, which is what's corroborated up here. And then we have the dramas, the comedy dramas and romances, and then we just keep going down. And we can also use this correlation method to generate relationships between each continuous variable. So if you run this, we can see how correlated each of these variables are to each other. Why this is important. Why is it important to figure out the relationships with each other? Because when you run machine learning models, what the network is going to do, or what the algorithm is going to do, is basically try to find relationships between the data, right? Because if you have a lot of variables, the goal of the model is to figure out which variables are very correlated with each other and which ones are very indicative of which of these are the most indicative of the prediction that the model is going to make. So when you look at this correlation, right, obviously one variable is going to be 100% correlated with itself, right? So if you go down the diagonal, you only see ones. But if you take a look at, for example, the rank and the year, right? So the year is negatively correlated with the rank. So it seems like if the movie is going to be older, then or the rank is the year is going to be earlier, then the rank of the movie is actually slightly higher apparently. So there's going to be an inverse correlation. And this is very useful if you're kind of trying to filter out variables, because as you guys will learn later, sometimes actually most of the time it's not good to have variables that have a high relationship or high correlation with each other, because then one of the values is basically useless, right? Because if you have a really high correlation between two variables, you can just summarize the data in those two columns with just a single column, because they're already very highly related to each other. Okay, last thing we're going to talk about is slicing with pandas and selecting/extracting data. So by now we've already seen how to extract a column by using these square brackets, and we can also get a type of the column, which is just going to be a series. And to extract a column as a data frame, this is very important. To extract a column as a data frame and not a series, you need to pass a list of column names, and this can be passed through these double brackets. Remember, double brackets means that you're going to get a data frame. So if you look at this example here, we're going to end up with a data frame rather than a series. Oh my God. So we end up with a data frame instead of a series. And since this is like a list, this is basically like a list notation, right? Because we're putting a list inside of the indices we want. So we can specify as many kind of values as we want now. So we can basically just add another column name very easily, and we can get the values in that specific data frame. So basically, this is useful when you want to basically select a few columns for the entire data frame, and you want to make a new data frame out of them. You can use these double brackets, and you can use this kind of list notation. So I talked about this already earlier, where LOC locates by the name and iloc locates by numerical index. The difference between iloc is iloc is just an integer location. That's how I think about it. So if you want to access like a part of the data frame using an integer parameter, then you would use iloc. Otherwise, you'd use LOC or loc. So in this case, we're using a string, right? So we're going to use LOC. We're going to pass it and basically get the entire column, right? No, this is a row. Prometheus is a movie. So we're going to get all the row values in the Prometheus row, which will basically tell us everything about the movie. And instead, we can do the same thing, but this time with iloc, and specify the integer row, right, or the integer index. So when you do this, we'll end up with the same thing. Sorry, let's put this out again. We'll end up with the same basically values, right? Because we're accessing the same row, but just in different ways. So in this case, we're using the string accession. And in this case, we're using integer accession. All right, and alloc and iloc can also be used similarly to Python slicing. So in this case, we can select multiple rows using iloc, or we can select multiple columns with the start and end being used with loc. So yeah, it's like pretty cool where you can select specific areas. So the first thing we're doing is we're selecting the movies with titles from Prometheus to Sing. So we're selecting these 3 movies: Prometheus, Split, and Sing. And the next thing we're doing is we're getting the first to fourth values of the rows. So in this case, all of these fall into the parameter list, which is why the movie subset is not going to change. But the slicing still works in the same way, which where you start with the index 1 and end on the index 3, right? So you get the values at index 1, 2, and 3. Yeah, one important distinction between a loc and iloc to select multiple rows is that, oh, actually, I forgot to bring this up. Loc includes the movie Sing in the results, but when using iloc, we're getting the rows 1 through 4, but the movie at index 4 is not included. So basically, you're instead of specifying by indices or integer indexes, where you would be basically getting, the indices 1, 2, and 3 with this command. Up here, you would basically get every single value, including Prometheus and Sing. So you wouldn't get for example, if you run this, you wouldn't only get Prometheus and Split. You get Prometheus, Split, and Sing because Sing is still in the index bounds as defined by loc. All right. The last thing, really quickly, sorry, we're going over a little bit today, is conditional selection. So say we want to select columns based on some criteria or select rows based on some criteria. We can use conditional selection to do that. So for example, here we're saying if the movie's director equals Ridley Scott, we want to get all the columns that have that. I'm sorry, we're going to get all the rows and columns that have that. So capitalize it. So basically, we can see that Ridley Scott was the director for these movies, right? So these are like 5 movies. He's director for these 5 movies. And similar to is null, this returns a series of true and falses. But say we want to get all the rows and columns for films directed by Ridley Scott, and not just the trues and falses for that specific column, we can use this outside parameter where we call movies df, or the data frame of the entire value. So when you run this, we'll get both the rows and the columns where Ridley Scott is a director. All right, someone's trying to join, I think. Okay, cool. So in this case, we're going to get all the different movies where he's a director, and we'll get the entire row, not just the specific column that has him as the director. All right. And next thing we can do is we can do comparisons. So conditional selection would be the same as normal, and then we can get the first 3 values here. Oh my god. And yeah, and we can also make some more complex conditionals by using logical operators. So instead of using or and, we'd use these bitwise comparisons. So we'd use this, I forgot, I don't know what this is called, it looks like a stick to me. I call it the stick, or like a straight up thing for or, and then use the ampersand for and. And this would basically give you, for example, this command right here would give you all the movies with all the rows and columns of the movies where the director is Christopher Nolan or Ridley Scott, right? So if you run this, we'll get all those movies, and we're taking only the first 5 of those. So that's pretty important, or pretty interesting to know. And you can also do something like group evaluation. So we basically can, instead of saying this up here, where we have this long statement, where we have this logical bitwise or in the middle, we can say get all the movies where the director is in this list of directors and get those movies. So this would actually return the exact same thing as this, but this is just like a, I guess, slightly faster way of doing it. We can also obviously do a bunch of ampersands or back to back to each other. Just make sure you watch your parentheses when you do that to make sure that each statement is like in its own set of parentheses. And that's all you have to basically watch. And you can also use a quantile function to figure out like what the first quantile is, and if it's below the first 20th percentile. So we can run this, and I don't want to fix this, but just fix the fix it. You just fix the capitalization of this. And yeah, right. Basically, yeah, you combine the logical operators back to each other, and you get the same thing as normal. And we'll finish the rest of it at the end. I don't want to go over too much time. But in essence, just a quick review, like for the last 2 minutes, I'll just quickly review what we talked about today. So in essence, what you need to know about pandas. So the first thing you need to know is that when working with pandas, there are 3 types of accessions, right? You have the lock, ilock, or the ix. And lock, you'd use it when you have non-integer indexing. So if you want to basically access values that are, if you want to access values by strings, with a string parameter, and ilock is going to be used when you want to access by integer parameters. So that's the first thing. And you have ix, which is basically a combination of both. You can use both integer and strings back to back with each other. The second thing, you can load CSV files or JSON files instead of making the data frames yourself, and that's a really important thing to remember. The last thing with pandas is that when you are comparing things with pandas, you can use logical operators. So you can use the bitwise OR, which is the like straight up straight line thing on your keyboard, or you can use the ampersand for and. That's the second thing. And the other thing is that when you want to get values from an entire data frame, instead of just getting a singular column, you basically say like the data frame of what parameters you want to pass. So that's kind of the 4 or 5 main things you need to remember with pandas. We'll do a quick review next time at the beginning, and I'm going to post this notebook for you guys to play around with and test things with. But at this time, does anyone have any questions before we're done? No questions? All right. Well, I'll see you guys next week. I'll post all this information to today probably, and you guys can check it out on Google Drive. But for now, we're all done for today. And if you have any questions at any time, just message me or Sam on Discord or Messenger, and we'll be happy to respond to you.